now that we built all 4 pieces, like I said earlier, we're going to assemble them in the assembly file. So there's different methods when you're working in Inventor. There's the top-down approach, which I'm going to talk about, and there's the bottom-up approach. And then there's the middle-out approach. That's another option. Obviously, the middle-out approach is in between the two. So the top-down assembly is where you have the assembly file, and you create it first, and then the components are created in there. So top-down means you start from one piece, and you build off that. The other one is the bottom-up approach. It's what you guys just did now. We built all the pieces, and then we're going to assemble it. The middle-out assembly is in between both. You start with some, build off that, and then some of them you bring in as well. So in most cases, you're going to use either the top-down approach or the bottom-down approach. So let me just pause this for a second. So now that we've built all the pieces, we're going to assemble it. So we're not going to use the part file. We're going to use the assembly file. Do we know the difference between the assembly, the drawing, and the presentation? Do we remember what the difference is? Part is where we model each part. Assembly, we're going to assemble the part. The drawing is where we're going to annotate everything. And the presentation is where we can make the video, the exploded view, the exploded everything, animation to it. Okay, pulling it out, pulling it in, and so forth. So we're going to use the assembly now. We're going to press create again. And now we're going to open it up. If you notice right off the start, there's different icons here now. Now we says assembly. It doesn't say no more sketch and so forth. The other option we could do now is if you could just do right click, you could do place component. That's one option. You could go up here and play place. You could do place from Content Center. That's stuff that are already built, like screws, stuff like that. You could get them from the Content Center. Then you have import Cad files. Somebody asks you, can you import Cad files into Inventor? Here you go. You can import them. All right? Electrical category. So the other components are, that are already installed on the software. Again, if you're using student version, there may be some objects or some things that will be blocked because they don't want people taking these versions, going to real companies and working off them. They're just for educational use. So that's why a lot of things they'll block out, or they won't work properly, or they'll keep crashing randomly. It's the student version that we're using. Okay? So we're going to go press place. And we're going to go start with our first piece. So the first piece you put is usually the piece that's going to be fixed. So the one you don't want to move around. So in this case here, we're going to use which one? Not the disc, because we're going to use that later on. We're making a sub-assembly first of the flange, the key, and the shaft. So again, the flange one I'm going to put first because that's the main piece. Everything is going to connect to that one guy. So let's go do the flange and press open. And now you notice it's going hovering around. If I do right click, I could do place ground at origin. What does that mean? It means it's going to bring it to 0, 0. It's what we want. I also have the option, as you see here, I could rotate it 90 degrees along the Y. Rotate it 90 degrees around the X. Rotate it around the Z or Z, however you pronounce it, 90 degrees. I can use iMates, which is intelligent mates, which means it's going to automatically constrain it for you. I also have home view, so it resets it. So in this case here, because it's our first piece and we want it to be grounded, we're going to do what? We're going to go use the option saying place grounded at origin. And like that, it places it. It also gives me the option that if I have more than one, I could place more than one. So if I go here, right click, I could place it again on the same piece. We're not going to do that twice. I could rotate it. See it? We're rotating the piece we want. In this case here, we don't need it, so we press escape. All right? That's the first piece we've done. Then I could go back, right click, and do place component again. I could go to the key. I could go to the shaft. I'll do the shaft first. I'll press open. So right now you notice the shaft is actually in the right place. All I have to do is rotate it so that the slot we made aligns with this slot here. So I could right click and I could rotate along which axis should I rotate? Along the Z. So I do Z 90 degrees. It went the wrong way. It's okay. Again and again. Now if you forgot to rotate this, is it the end of the world? No, you can rotate them later on. but by placing them at the same time and fixing them, it kind of saves me a bit of time later on. So I'll place it right now. I'm just going to place it not using the iMates. I'm just going to place it normally. Oops. Oh, crap. Rotate, rotate, rotate. I'm just going to place it down. Okay, give me 1 second. Now that we've added that, the next one we're going to do is again place. Again, I could have done place this way. I could have technically just in SolidWorks you could drag them in. I could click key, or I could do right click, place component. Let's go do the key option, press open, and now remember, this one here we did it with a draft of 1%. So now we're going to right click, rotate it. Which way should we rotate it? Along the Z, so that we have the shaft going the other way. So this is the wrong way. Let's go rotate again. Rotate again. So now we notice this is going to be the correct way. We're going to see later on that once we place it, that this is the 1 and this is the -1. Okay? But again, I did it no, it's correct. So let me just, now I have the 3 parts. Let me just quickly pause again and give you 1 second. Yes. Okay, so now that we've placed the 3 parts, we're going to constrain them into the actual piece. So now we're going to go use constrain. Watch. Now we're going to grab the center of this object and the center of this object. We see it? Look, I just clicked constrain, center, grab the middle line, and the center of this. Watch this. It automatically threw itself into its place. That's beautiful. That was the easiest one we could do. We're going to press OK. And now you notice I could still move it. I still have the degrees of freedom. It's still able to rotate it and move it around. I think, if I'm not mistaken, the degrees of freedom will pop up right over here. Degrees of freedom. See? In this case here, I have 6 degrees of freedom over here. This one here I'm able to just rotate it and move it up in the one direction, both directions. We see that? See how I got the degrees of freedom? Under view, degrees of freedom. View, degrees of freedom shows me how much movement I have. The one that I fixed to the origin, how much degrees of freedom do I have? 0, because it can't move. So now that I place that, we're going to do another way. We're going to constrain the back face of this piece, which is here, to this place over here, the plane over here. So we go do assembly, constrain, this face with this face over here. And I'm going to make them parallel to each other. I don't want them to go against each other. I want them to go flush to each other, not parallel, flush. So we notice, if I zoom in over here, that they are flush to each other, and I only have now 1 degree of freedom. If I press OK, you see that I only could rotate the actual object. We see that, right? If I'm not mistaken, I don't know if I'm mixing up Inventor with SolidWorks, but you should be able to play the degrees of freedom. I think I'm mixing up this with SolidWorks. Yeah. In SolidWorks, if I'm not mistaken, this one doesn't seem like I have it. In SolidWorks, there is a button you could do called Driven. What it does is if you push it, it'll tell you what degrees of freedom it can move. So if it could go this direction, it'll go up and down. If it could go left and right, it'll go left and right. If it could rotate, it will show you the degrees of freedom. In this one here, they'll show us with the little symbol that we see over here. It's just fixed on rotation. So now this case here, this is the wrong one, right? This is not complete. This should be the opposite. This should have been on the other way. So what I can do is I could go back and get rid of the flush. Right click, delete. And I can pull it back out again. We saw how I did that? I went back and I deleted the mate that I did before. I could go back to this one, delete. Oh, here we go, driven. Now it shows it. Driven, it's going to show me, if I press play, what did just happen there? Well, it just flew. It's showing me that it could go up and down, see? So now let's go back, and let's lock it into place. So this one here should be which way, guys? So which means this little piece here should be on the inside, correct? So yes. So we should have done this. I should have did constrain. Try not to rotate the pieces. You could do it using constraints. Grab this face here, right? Shift, pan over the other side, and grab this face here again. See? Now, if I go look at it, is this correct? No. So if I flip it, No, I don't have to rotate. It should do it by itself. I think, hold on, something's wrong here. Let's do it again. Constrain. I think this first main is stressing it up. Let's delete this one here. I'm going to delete it. It's easier. Go in here. I'm going to show people how to delete and modify. Let's go back. Let's do the face one first. Let's grab this face here with this face here. Okay. And now let's flip it. There we go. This is the correct way. So I flipped it to the other direction. If I press OK now, you see that it's flush with the side that I want. Now I can do constrain, the center to the center, apply. Oops. I grabbed the wrong center. The center of this piece with the center of this one. Why is it giving me an error now? Hold on, something went wrong here. Hold on, guys. This one should be flush, which is okay. So now if I do constrain, this center with this center, aligned. There we go. I was on the wrong one. I had to do opposed. It should be aligned. If I press OK now, you notice that they are locked inside the piece. It's only one more degree of freedom. The last step to do is I'm going to align this piece with this piece. Constrain this line here with this line here. Accept. And you notice this guy here no more has any degrees of freedom. It is fully constrained. We see that? It's not moving anymore. All that's left to do is put the key. So now for the key to see which one it is, I go to the right view and I look. This looks like it's, the draft is going down. Let's see. Let's see from the top view. There we go. So now we can see it. Change the views around. You notice that this is actually the lower part. So what I can do is I could pan shift and do plane, constrain, the back face with this face. There we go. I can accept it. So most times what you can do is you can use a constraint to get to the shape you want. There we go. That's the flange still. It's still good. And now we're going to go do constraint this face here with this face here. And I'm going to flip it. Accept it. And now I'm going to do constrain this face here. We're going to test it. If it's no good, I can always change it. Constrain this face with this face. Oh, wrong one. No, I did the wrong orientation.
It would be easier to see if you hide the shaft.
Yeah, we're going to hide this guy here. Again, oops, how did I do that? Sorry, I went too fast without showing you how I did it. Is I clicked on the flange and I went and did visibility off. Okay? So now I just want to double check. So this is okay, but I think I'm going the wrong. No, it was right. It was good. No, it's good, no? Yeah, so if I go back here and do constrain this face here with this face here, there, it's good. It's actually perfect. Because it's going in, and the smaller one, if I go to the left view, it's the smaller one going inside the piece and the bigger one going on outside. So it's actually pretty good. So now if I go back and I show the flange, where's the visibility? See, this is perfect. And I have 0 degrees of freedom. I can press the home button and it's perfect. Once that's done, I could save it. There's also methods where you could use the planes. It's going to show you could use a plane to constrain it. Any method you use that works for you is perfect. So now that I have no degrees of freedom, if I go do inspect and I go analyze and I select everything, press OK, you notice that I have no interference. So how do I know when I have interference? So let's just show you. If I place a new piece, let me just add this key here, okay? And I'm going to physically put it so it's cutting through the actual piece. We see it? That it's touching the actual piece, correct? So now I go back to, where is it? Inspect, and I go analyze. If I select everything like so, and I do OK, what do you notice it tells you? It tells you that there's something rubbing against the other piece. So if my key wasn't correctly done here, it would have told me that the key is rubbing and there's interference inside that piece. It would even tell you the flange and key 2 there's an issue. There's a volume error of this, and it tells you the type that we have. It kind of gives you all the information it's telling you that there's interference. So if I go eliminate the interference in this case, and I go again analyze, and I select everything, press OK, there's no interference. I could have also done interference between this piece and this piece. None. So I could do independently, or I could select everything. So because you don't want to have interference when you're putting something together. Obviously, if you are doing a Lego piece, for example, you're going to have a whole bunch of interference. Why? Because the Lego piece, you have to snap it into place. Or else when you flip it upside down, it's going to come out. This piece here, if I go a little bit more tighter in, I'm going to have interference because it's the pressure, friction. We understand that? So that's how we check to see if we have any interference. Yes. Resume. So now that we have this piece completed, right? The next step we can do, again, there's multiple different ways of constraining it fully for whatever object we're working with. It's up to you to decide which one works best for you. For me, instead of rotating, like I said, I use a constraint. It flips it for me. Then I delete the constraint. You, and then I can say, Rob, no, that's a waste of time. I rather rotate the piece and then do it. It comes down to your preference, your speed, whatever you want for it to work. But now that that's done, I'm going to do File, Save As. And I'm going to call this one as Subassembly. Okay, I'm calling this as a subassembly. And I'm going to press Save. Why did I make a subassembly? You're going to see why in a few seconds. Now that this is done, oops, I'm going to close this. And I'm going to go New again. And I'm going to open up a new assembly. I'm going to press Create. All right? So now this one here, what's the first piece I'm going to place this time? Is I'm going to place the disk. All right? So bear with me. You guys are going to see it. That's going to work. We're going to put the disk, open, and we're going to do like we did before. Right-click, place ground at origin. And that's all we need, one piece. Now, if we didn't make that subassembly, what do we have to do now? We would have to make the disk, the flange, the key. Then we have to make it, connect it, and do all that steps we did earlier. But by having a subassembly like we just built before, I just press Open. Here's one subassembly. Then I can go back here, rotate it. Oops, wrong direction. Rotate along the X. Perfect. So I rotate it both ways, and I click it. And now I have one of them that's already aligned to this piece, and one that's already aligned to that piece. So I have my subassembly. So now when I'm constraining it, it's going to be a little bit less hard. Because why? I could go do this circle with this circle. Press OK. Let me go show you my degrees of freedom. See, I still have a lot of degrees of freedom. I can still rotate in multiple directions. So I could go back again, do constrain, rotate this face here with this face here. Now it's locked to only rotating. All I have left to do is do this. Constrain, got a little bit closer so I could see it. Constrain this piece here with this piece here. Apply. And now you notice it's locked into place. I'm going to do the same method I just did over here, but to the other side. Constrain. You could go whichever way. You could do center to center. I do this face here with this face. Apply. And it still moves it around. I could go pull it back out a bit. Constrain this face. This face here, I said, to this face here. Oops. There's something wrong with my last one. I did too many mates for that one. This one here is no good. This is the other piece. This is the first one. Where's this guy? This guy is here. So let me get rid of this guy. Delete. See, sometimes it may seem like I did the same ones twice. So let's erase both of them. Let's go back and pull it back here again. Let's constrain this time the center. Let's do a different one. Center to center. There you go. Apply. So now we know it's locked in the center. Then I could do a simple one. I could do constrain. Pull it out. Constrain this face here with this face here. Align. So now it's perfectly aligned. All that's left to do is just do this face with that face. This face here with this face here. And now if you notice, I have, if I press home, I have 0 degrees of freedom whatsoever. And if I go check interference, so I go to Inspect, Analyze, I'll select everything this time, press OK, none whatsoever. Now that that's completed, I could go here and do File, Save, and call it I could call it the whole thing. I could call it Oldham Coupling because it's completed. Okay, and I'm going to press Save. So on the next video I'm going to show you how to animate it. So let me just save this video.